Okay, let's give you guys some more practice. So work out the limit of this as x tends to 0 from the right hand side. Okay, so because if you look at this, what you've got here is one block multiplying another block. If you look at this block, you've got natural log looks like this. You can't really say find the limit as x tends to 0 because tends to 0 means you approach it from the right hand side and from the left hand side. But if you look at the domain for this, on this side it's meaningless. That's why we can only have a one-sided limit. So work out the limit of this as x tends to 0 from the right-hand side only. Okay, so press pause and have a go. Okay, so to do this, you've got one block multiplying another block. So if you look at this, as x tends to 0 from the right-hand side, this block here will head towards 0. And then as x heads towards 0, this thing here is going to head towards negative infinity. So because natural log looks like this, if this block is heading towards 0 from the right hand side, you are heading towards negative infinity. That's this negative infinity. So here you've got 0 times negative infinity. So here you've got a product. So turn that into a fraction. So hang on. So currently this thing here, as x tends to 0 from the right hand side, this thing here will head towards 0, and this thing here will head towards negative infinity. So here you've got a product. So you've got to turn it into a fraction. So let's visualize this thing here as this. Let's put the 3 in here. So visualize it as one block multiplying another block. So whenever you have a product, you can always turn it into a fraction by visualizing it like this. So here, turn it into a fraction. It will look like this. And then now check. As x tends to 0 from the right hand side, this thing here will head towards, it will look something like this. As x tends to 0 from the right hand side, is heading towards negative infinity. So this thing here will be negative infinity. As x tends to 0 from the positive side, this thing here, now 1 over x looks like this. As x tends towards 0 from the right hand side, so from the right hand side, it's heading towards positive infinity. So here we've got a case where it's infinity over infinity. So now we can apply L'Hopital's rule. So differentiate this. That will then give you this. And then differentiate this. That will then give you this. Now tidy this thing up. That will then give you this. So now let's evaluate it. As x tends to 0 from the right hand side, this thing here is going to head towards 0. So the answer here is 0. Okay, next question. So work out the limit of this as x tends to positive infinity. So press pause and have a go. Okay, first let's visualize it like this. So as x tends to positive infinity, this thing here is going to head towards infinity. And then remember, e to the x looks like this, minus e to the minus x looks like this. You've got a 7 here, so it's going to look something similar to this. So you can see that as x tends to positive infinity, it's heading towards 0. So here we've got a case of a product where you've got infinity times 0. So whenever you have a product, you can always rewrite it as a fraction. So rewrite this thing here as a fraction. Rewrite it as so rewrite this thing as a fraction. So rewrite it as this. So this thing here is actually this thing here. It's actually this thing here. So this is exactly the same as this. Because if you have, let's say, e to the minus x, if let's say you've got, let's say x to the minus 3, you don't understand what it means to have a power of a negative, you would jump to 1 over x to the power 3. Well, if you have x to the power 3, you can always jump to 1 over x to the minus 3. So here you've got 1 over, you can always work, this thing here is equal to this thing here. Think about it. This thing here is equal to this thing here. So now we are currently here. Now let's try and evaluate it as x tends towards positive infinity. As x tends towards positive infinity, this thing here will head towards infinity. As x tends towards positive infinity, this thing here will look something like this. As x tends towards infinity, it is heading towards infinity. This thing here is heading towards infinity. So here we've got infinity over infinity. Therefore, we can apply L'Hopital's rule. So, hang on. So, apply L'Hopital's rule means you can differentiate this. That will then give you this. Differentiate this. That will then give you this. Now, evaluate it. As x tends towards infinity, this thing here will tend towards infinity. So here, a 4 is constant. So this thing here is heading towards infinity. So here you've got a number 4, and this thing here is very, very big. So that thing very, very big would ultimately mean you're heading towards 0. So the limit here is 0. Okay.